Hello, welcome to today's YouTube video on application of Newton's laws of motion. A sack of mass 80 kg is pulled up an incline by means of a force 900 Newton. A friction force of Fx 40 Newton acts between the sack and the inclined surface as the sack is being pulled. If the angle the incline makes with the horizontal is 30 degrees and F makes an angle of 45 degrees with the incline, what is the acceleration of the sack? So what we are going to do is to identify this body. We have identified it. So the mass, the spring that is used in pulling it, we have identified it. There's a reaction force that will be here when you put it. So there will be a reaction force perpendicular to this incline. The weight will act vertically downwards this way. This guy is acting this way. So there will be a frictional force as we move it up. So what we now do is to draw the free body diagram. So to draw the free body diagram, we'll draw a line, and in order to simplify this problem, we will orient our axis to be parallel to the incline. So this is parallel to this incline. So the reaction force is acting here. The mass is assumed to be here, so it's R. It's assumed to be here. So the weight is acting downward. The weight is acting downward, mg, if you like. If we extend this to a point and draw a line that is perpendicular to this line, you find out that this angle θ1 will be equal to this angle θ1 by trigonometry, geometry. So there is a force dragging this thing F. So there is a to this incline. Here is a F. This is θ2, F sine θ2, and here is F cos θ2. So here also is mg cos θ2. You can see our video on SOHCAHTOA to see how these things are derived. Here is mg sine, opposite to this angle, sine θ1. So we have put in all the necessary things. So here, for convenience, we are going to take we orient our axis so that here now is our positive y-axis parallel to the incline, perpendicular to the incline, and parallel to the incline is our x-axis, positive x-axis. So you see that it's parallel to this. This one is parallel to this. So from here now, we're going to just we say along the incline, if we apply Newton's law, sigma F, so along the incline it will be sigma Fx is equal to max along that incline. So all the forces acting along the incline is this one, F cos θ2, mg sine θ1, and the frictional force that is acting downward this way. Frictional force that is acting downward this way. So you have it to be minus, since anything this way is minus x, anything this way is minus y. So it's minus Fx minus mg sine θ1 plus F cos θ2 is equal to max. So we are trying to find ax. So we now say that ax equal to 1 over m into f minus fx minus mg sine θ1 plus f cos θ2. So that we see that is equal to 1 over the mass is 80 kg. The frictional force is 40 Newton minus 80 times 10, 80 times 10, 800. Then sine theta 1 is 30, plus the force dragging it up is 900 cos 45. So that's it. So I'm going to use let me use you can see that this one will cancel 1, okay. So we have 1 over 8 into minus 4 minus 80. Sine 30 is half, 1 over 2 plus 90, cos 45 is 1 over root 2, that's 1 over root 2. That's what we have. So that we have it to be 1 over 8, that is our AX, into minus 4 minus 40, because this is 40, plus this will give us 90 root 2 over 2, that's 45 root 2. That's what it will give us. So that when you do it, you get the answer to be approximately 2.46 meters per second squared along the incline. That is how to do this type of thing. Please subscribe and click on the notification button so that whenever we put on new videos, you follow us and enjoy. Bye.